Hello again, and congrats on making it to the 10th and final lesson in my Introduction to Maya series. So far, you've learned how to build this model, light and shade it, and even animate it with some classic animation principles. With these skills, you've successfully made it to the edge of the newbie sandbox. Now, don't get me wrong, you could easily stick with just these three disciplines and keep refining your craft. Whether by building more and more complex models, developing beautiful, realistic shaders, or animating clips for short movies or video games. In fact, many artists carve out entire careers around mastering just one of these core fields. But one of Maya's strengths is that it's a great end-to-end solution. That means it offers an entire world of paths to explore and expand upon these core disciplines to fully execute on your creative vision. Things like dynamic VFX, match moving, motion graphics, hair grooming, rigging, rendering, and more, all using industry standard tools and techniques employed at, and thanks to our ongoing industry relationships, even co-designed by some of the world's biggest and brightest studios. Of course, it'll be impossible to cover all of these in a single video. I'm barely experienced with some of them myself. So for this finale, I'm going to lightly touch on as many as I can while finishing off our rocket scene. I apologize in advance because this is going to be a long one, but if you're serious about learning the biz, it should teach you a lot. So by now you should be pretty comfortable using deformers to change and reshape geometry. Maya ships with a pretty good collection of them up here in the deform menu. But what if I want something custom? Well, with a little ingenuity, you can actually engineer your own deformers. But first, let's replace the grid with a much more pleasing flying platform. By the way, I challenge you to use the skills you learned in the previous lessons to recreate this. I'll include the textures in the link below. Now, as part of our anticipation, we used a squash deformer to squash the ship down before takeoff. As great as that looks, I want to take it one step further by having my rocket wiggle back and forth like it's really getting ready to blow. Unfortunately, Maya doesn't have a wiggle deformer by default, so let's make one. As the base for my wiggle, I'm going to apply a lattice deformer. This creates a cage around my object. And if I move the lattice points of the cage away from the base, the rocket deforms with it. In particular, if I reduce the number of divisions, like so, and just move the top vertices, you can totally see a wiggle in the making. Now I just need to animate this. Except individual components don't appear in the attribute editor or channel box. So how am I supposed to keyframe them? Well, I can deform them as a cluster. This creates a handle for them, denoted by this C, with all the usual move, rotate, and scale attributes I need for animation. By the way, you can cluster a lot more than just lattice handles. They work on things like curves and even geometry vertices too. Now, I could keyframe this by hand, but that'd be kind of painful. Instead, let me show you a little trick. Similar to something like an Excel or Google spreadsheet, you can actually enter expressions into these fields. In this case, I'll enter the following. This assigns it a random number between negative 0.45 and 0.45 per frame, which I'll then repeat for translate Z. And there you go, automated wiggle. All that's left to do now is parent the base and lattice to my rocket so they don't get left behind, and scale them so they encompass my rocket even in the squash and stretch state. Finally, to turn the wiggle on and off, I can keyframe the cluster's envelope value. So although I'm pretty happy with my wiggle animation, it's kinda messed with my timing. I'd prefer the rocket spent a little more time charging up before liftoff, plus now the launch will need to go a lot faster given all the energy it's got. In lessons 8 and 9, I showed you how to adjust the timing of keyframes, so I could just retime the motion path to lift off a bit later. But that makes it so my squash and stretch doesn't line up anymore. So I need to retime that too. But then of course I'd need to retime my cluster too. And if I do all this and decide I don't like it, well then I have to go back and do it all again. That's a pretty clunky workflow. Instead of doing things this way, let's combine all the animations related to the rocket's flight into a single animation clip that will modify them together at all times. First, I need to take stock of all my animation sources. That includes my motion path, squash handle, cluster, and aim locator. So I'll first go to my motion path, making sure to select it so I can see the keys in the time slider. Then I'll go to Windows, Animation Editors, Time Editor, and click this big plus button. Maya adds an orange clip to my track, which now controls the rocket's flight. Also notice that the motion path attributes have changed from red to yellow, indicating that they're being driven by the clip now. Now I'll just dock the time editor down here to make it easily accessible. Then repeat for the squash and stretch, again making sure I have the right thing selected. This time, I'll clip it using the little add button up here. And Maya adds a second track for my squash and stretch. Then I'll repeat once more for the cluster and aim locator. And finally, I'll rename all these clips appropriately. Now this is a format a lot more of us are familiar with. In fact, it looks a lot like the video editor I'm using right now to make this video. Now I can group all these related clips together, then split that up into different stages like pre-launch, takeoff, and flight. Now I can simply scale clips to retime them, which is a lot easier than what I was doing before. Now, unfortunately at the time of filming, there's a bug where the time editor won't capture a motion path's inverse front value. Notice that it doesn't appear in the list of attributes under the clip, and the ship now flips too early. Hopefully this is fixed by the time you're watching this, but even if it isn't, don't worry. I can just modify the up twist value here instead, which is honestly probably what I should have done in the first place. So I'll right-click Inverse Front, and then select Break Connection to remove its old keyframes. Then in the time editor, I'll select the clip, and click this button to go to its graph editor. From here, I can modify the individual elements that make up the clip, just like I showed in part 8 of this series. In this case, you can see the two animation curves corresponding to the motion path's U value and up twist. To make them more obvious, I can switch to absolute view, and then recolor one of them. Now, just like before, I'll go to the frame where the rocket flips, where I already have a small uptwist keyed as indicated by this spike. I can center the frame on it by selecting those keys and then pressing F. And then shift middle drag this last key straight down. Notice how the rocket spins as I adjust the keyframe's position. And it should come as no surprise that a value of about -180 does the trick. Next, at the moment it lands, I'll insert a couple of new keyframes using the Insert Keyframe tool. And then reverse what I did before. And while I'm at it, I'll change these tangent types to stepped so that their values immediately jump from 0 to 1 with no slope in between, essentially mimicking the Boolean on-off attribute we were using before. It's also worth noting that you can only edit unscaled clips this way. For instance, I wouldn't be able to do the same for the pre-flight or takeoff clips unless I returned them to real-time first. All that's left now is to split this into its own landing clip and touchdown to mirror the pre-flight and takeoff. You can learn more about the high and low level editing abilities of the time editor in my lesson on non-destructive animation editing. One technique that you're bound to use often is creating custom control curves. Most often you'll see this as part of a character rig, giving you control over its various appendages. However, they can be useful in a scene like this too. For example, suppose I wanted to transition from this cloudy skydome to a more appropriate space skydome as the rocket gets closer to the moon. First, I'll create a second AI skydome light with an appropriate EXR file. Then rename those two lights Earth Skydome and Space Skydome. But the question remains, how do I switch between them? Well, I can effectively turn off either skydome by first reducing its intensity and camera to 0, along with the associated file's alpha gain. But 2 skydomes means that it's 6 steps just to switch from one light to the other. That's a lot of work just to swap a background. Instead, let's create a control curve with a custom attribute that does all of this at once. I could use any object as the base for my controller, but NURBS curves are the traditional choice. However, rather than using a generic shape, let's create something a bit more meaningful. In the polygon modeling shelf, I'm going to click this big T, which is the type tool. This creates some 3D type in the viewport, which I'll change to C for control, and then resize and reposition it. After that, I'll go to the Geometry tab where I can create a NURBS curve version of this polygon text. And then I'll just delete the polygon version, bring the curve up to the root level, and rename it. Now that I've got my C, I'm going to create a custom attribute on it in the attribute editor by going to Attributes, Add Attributes. I call this new attribute Earth Space Lighting and give it a range of 0 to 1. And now if I look in the Extra Attributes section of my scene control, I have a new slider. But of course, it doesn't do anything yet. To hook it up to the skydome attributes, I'm going to go to the Node Editor. The Node Editor is probably Maya's single most powerful tool. It's sort of the equivalent of looking under Maya's hood. If you want to know more, I have a whole other tutorial on Maya's node graph. But for now, let's use it to plug our scene control into the skydomes. To display what I need, I'll middle drag in the scene control and 2 skydomes from the outliner. Then I'll click the right side of my scene control to select my outgoing custom attribute. then plug it into the space skydome shape node. I'm looking for intensity in this case, which I don't see here, so I'll hit Other. And if I scroll down, there's the intensity attribute. Now that the two are plugged together, watch. As the custom attribute changes, so does the skydome's intensity. Next, I'll hook the same outgoing attribute into the skydome's camera attribute, which turns this line orange, signifying that it represents multiple connections now. Now let's do the same for the Earth skydome. However, in this case, their relationship is actually reversed. When this value is 0, the Earth light intensity should be 1. No problem, I'll just hit Tab down here and create a reverse node first. Then filter the value through that. And then I'll repeat for the camera input again. Next, I need to hook up the skydome's alpha gain values the same way. However, these values aren't on the skydome shaped nodes themselves, but rather on the associated file nodes. No problem, I'll just select both skydomes and hit the Show Inputs button up here. This shows me the associated file nodes feeding the skydomes, which I can just hook up the same way, this time looking for the alpha gain attribute. And now if I slide the custom attribute back and forth, the lighting changes. Not only that, but this new slider is even keyframeable. And clippable in the time editor. Giving me a fully controllable Earth to space transition whenever I want it. So now that my rocket and background are animated nicely, I'll want to set up some epic camera shots to match. Every Maya scene comes with a few standard cameras, like the perspective view I'm on now, or the 3 other orthogonal views in the 4 view. I can create new cameras simply by going to Panels, Perspective, New. Now, cameras in Maya are treated just like any other object. Notice in the outliner, you can see the default ones, which are pre-hidden already, as well as my new one, which isn't. I can even rename it, just like any object. And if I switch back to the default perspective camera, I can actually see it in my viewport and move it around. Note that moving and rotating a camera externally like this is the same as tumbling, tracking, and dollying when you're looking through it. Now, to easily animate a camera, just maneuver it into a start position, then select it in the outliner, and set keyframes on the appropriate attributes like you would for any other object, in this case, translation and rotation. Then I'll go to a later frame, reposition, and set more keyframes. And now you see the camera moves. If it doesn't move exactly as you like, you can always insert intermediate keyframes too. And you can adjust the slopes in the graph editor to tweak the speed, though I quite like the speed of this already. However, I do think I'll briefly go back to the time editor and delay my takeoff until after the camera is in position. And that does it for my establishing shot. For shot number 2, I'm going to tuck the camera in behind the rocket for a dramatic follow-along. Then to get it to follow the rocket, I'll select it, and then my camera, and in the animation menu set, go to Constrain, Parent Constraint. You'll want to make sure this Maintain Offset setting is turned on, just so the camera keeps its current distance. And now the rocket constrains the camera's movements. For my last 2 shots, I'll do an inverted version of my second shot to capture the landing, once again using a constraint. Before ending on a close-up of the touchdown itself. And finally, I'll hide all the cameras and put them at the top with the others. Now that I have a bunch of different shots, how do I assemble them? Well, there's actually a couple of answers to this. In a large professional production where an entire post department would be doing compositing after your 3D work, I recommend Maya's render setup feature, which you can find via the link on your screen. However, that's a whole other subprofession unto itself. For a first animation like this, I'm going to use the much simpler camera sequencer. This is still more than enough to accomplish what I want. Notice how much it looks like the time editor we used previously. It functions pretty similarly too, albeit in respect to cameras instead of animation. I'll start by switching back to my shot 1 camera, then rewinding the scene and clicking this button to create a shot for it in the sequencer. Just like the time editor, this creates a track representing my shot 1 camera. Of course, this doesn't really do much with only 1 camera, so I'm going to go to a later frame here, and then right-click and split the shot in 2. Now I'll right-click the second clip again and switch the camera to shot 2. At first this doesn't seem to do much when using the viewport time slider, but if I scrub in the sequencer, the camera changes. Then I can split the shot again during the landing to switch to shot 3. And once more at touchdown for shot 4. And now if I hit play in the sequencer, I get a full sequence of shots. Now, although this looks okay, I'd like to make a few timing changes. First, I'd like the camera to linger on the first shot just a bit after takeoff. So I'll drag these frame numbers in the top left and right of each shot to change their frame range. The only problem now is that because shot 2 starts later, it captures the Earth-space transition at the wrong time, while also completely missing the upward portion of the launch. To compensate for that, I'm going to go back to the time editor and split my takeoff at the moment the rocket leaves shot 1. Then delay the rest of the launch until later. Of course, this leaves a weird gap in my timeline where the rocket just hangs in the air. But from these shot perspectives, viewers will never see that, so who cares? Hollywood and video games are full of smoke and mirror tricks like this. Speaking of smoke and mirrors, another thing I'm noticing is that the rocket's takeoff happens awfully fast in shot 2. I'd love for the launch itself to be a bit longer. So I'll go back to the time editor and scale it using scale mode. While that certainly elongates the takeoff, now it looks too slow. To get back that feeling of speed, I'm going to select the shot 2 camera and animate its focal length. By reducing the focal length, I can mimic the sense of the rocket speeding away from the camera. Watching this though, I think I'll slow down my flight path a bit to even out the added sense of speed. And then adjust the shot timing to match. Finally, as the rocket approaches its landing, I need to undo the effect. To add an even greater sense of speed during flight, I can use the same trick I used to wiggle the rocket at pre-launch to add some camera shake too. This time I'll randomize values between negative 0.005 and 0.005, which might not seem like a lot, but a little bit of shake goes a long way. As a final touch, I can animate the visibility of the platform to hide it after the rocket takes off. And replace it with an Earth sphere to give a sense that the rocket has traveled a long way. And once everything is sequenced, I can play blast a video like so. You can also combine all these individual shots into a single Ubercam, which can then play in the viewport. However, Ubercams have strict requirements, one of which is that the cameras can't be constrained to other objects, which two of ours are. Notice how that causes the camera animation to break here. No problem, I can just delete that Ubercam, then select the offending cameras, and go to Key, Bake Simulation. This transfers the camera's movements onto the cameras themselves, as shown by all these new keyframes down here, rather than relying on a constraint. And now if I create another Ubercam, it works perfectly. Well, almost perfectly. We lost the shake on shot 2 because expressions aren't captured in bakes. But I can just break the old connections and redo that. I also need to animate the shake turning on and off just for shot 2. It's been a long journey, but the good news is we're almost done. The only thing we're missing are some dynamic effects to really punch up the scene. I'll do this using Maya's newest feature, the Bifrost FX graph. Now, like I said with render setup earlier, dynamic effects is an entire sub-profession within 3D. You could spend years just owning and perfecting that craft. We don't have that kind of time right now, but if it's something that interests you, then I highly recommend exploring my Bifrost playlist in the link above. But the nice thing about Bifrost is that you don't even need to know everything about it to get some benefit, thanks to the pre-made effects in the Bifrost browser. Here you'll find a bunch of common effects that you can simply drop into your scene, like this procedural cloud. Double-clicking imports the cloud, as well as the Bifrost graph that makes it, which might look complicated at first, but really just works like a bunch of Lego blocks plugged into each other. Starting from left to right, we can see that Bifrost creates an invisible sphere, which is then used as the base for generating a cloud, which then has a cloud material assigned to it before being output into the scene. Just like other primitives created from the shelf, you can adjust things like radius or position of the source sphere, which in turn affects the cloud as well. Or you can just interactively transform the BIF object in the outliner. One thing to note is that at the time of shooting this video, Bifrost isn't compatible with ambient occlusion, so you'll notice I have that turned off. Depending on when you're watching this, you may or may not have to do the same thing. To adjust the look of the cloud, I can go back to the Bifrost graph editor and select the cloud volume node, then adjust some properties in here. To improve the quality, I can reduce the detail size. Just know that doing this will increase the complexity of the cloud, thus slowing it down. So don't lower it too much until you're ready to output your final render. More on that in a bit. Finally, I'll keyframe the BIF object's visibility so it disappears when the rocket clears the moon. Lastly, it's time to add a smoke trail. Once again, there's a pretty good preset I can use in the Bifrost browser. Now, dynamic effects like this follow a totally different paradigm from the way we've been working before. For instance, notice that if I play now, the sphere flies off without taking the smoke with it. This is because, unlike keyframe animation, which animates predictable paths based on some sort of start and end state, dynamic effects aren't nearly as straightforward to calculate. In this model, the state of each frame depends on what happened in the frame before it. This is actually covered in one of the classic animation principles I didn't get to talk about in my previous video, called straight ahead versus pose to pose. To do straight ahead animation like this, I just need to change the playback speed down here to play every frame. And once I do that, the ball takes off with a smoke trail. Now, adapting this to my scene will be a touch more complicated than my cloud since the object in question is moving. I'll actually need to modify the graph a little bit. First, I'll create a new cylinder in my scene, then scale and position it directly under my rocket, like so. I'll then rename it Smoke Source, parent it to my rocket, and hide it. Meanwhile, back in the graph, everything starts at this animated sphere node. However, I'd like to substitute it for my cylinder instead. So I'll just middle drag in my cylinder like so, and then plug it into the same fuel source up here. Don't worry about matching this second connection, it's just outputting the sphere so that it can be displayed in the viewport. But in our case, we don't even want to see the cylinder, so I'll just delete it. And now if I play the scene again, you'll see the smoke generates below the rocket this time. Again, the slower playback is due to the intense calculations going on behind the scenes. But sure enough, once it takes off, the smoke goes with it. One trick you can use to temporarily mitigate this performance hit is to go to the smoke settings node and temporarily adjust the scene units smaller. This will treat the smoke as if it was coming from a toy rocket rather than a full-size rocket, generating less detailed smoke but speeding up the sim at the same time. This is totally fine when I'm refining the behavior, then I can just turn it back up again later. Likewise, I can increase the fluid detail size in the source air node to reduce the detail in the smoke, speeding it up even more. While I'm here, I'll also change the start frame to 48, since that's when my camera gets into position. And I can stop emitting smoke once the rocket leaves the atmosphere. And now the playback is noticeably faster. Another thing I want to do is give the smoke some initial speed, since it's supposed to be exhaust. And set the initial direction of that speed to -1 in y, so it goes down. To stop the smoke from going through the platform like this, I'll need to set it up as a collider. So I'll middle drag the geometry into the graph and plug it into the collider node. And finally, you can increase the dissipation influence rate to get the smoke to fade away faster. Again, that'll just help with playback performance a bit since there will be less smoke on screen overall. You'll notice that the smoke seems to collide way above the platform. This is just because of the incorrect scene scale I set earlier. It'll fix itself once I set that back. Actually, I do have a much more in-depth version of this same effect in the video linked above, so be sure to check that out if you're interested. To view the scene at full speed, you can go to Windows Play Blast to produce a real-time video, much like you did with the camera sequencer. Or you can try rendering the final result, a process used to produce beauty images with even more lighting, reflection, and other effects. You can render a single frame by going to Arnold Render. Note that just like VFX, this process can take a little while because of all the mathematical calculations, like light bounces, that need to take place. Or to render the entire animation, you can adjust the settings to spit out multiple frames. Then in the rendering menu set, go to Render, Batch Render. This will run the render process for each frame of your animation in the background, leaving you free to continue working. Once it's done, you can go to the current project's folder to find a series of image files, which you can then open in an image sequence viewer. I like DJ View, but there's a few different options out there. So that's it for my introductory Maya course. Hopefully now you have a good feel for all the different things that Maya can do, and more importantly, all the different ways that it can do those things together. And of course, it goes without saying that what I've shown here isn't even close to an exhaustive list of capabilities. Where you go from here is completely up to you. For instance, you could easily spend hours just artistically fine-tuning this one scene in order to make it perfect. Or you could move on to learning how to rig characters in order to animate them for video games or films. Maybe you could try your hand at some motion graphics like title cards or animated logos. Or go down the dynamic effects rabbit hole with more Bifrost. Or even learn some advanced rendering workflows in order to prepare your 3D assets for compositing into real-life footage. And that's the key takeaway I want you to graduate from this series with. That Maya isn't just a single 3D tool. It's an entire platform with nearly endless possibilities. That's why big budget and indie studios alike continue to build their film, games, TVs, and advertising pipelines on top of its strong foundation. So congrats on taking your first step towards joining them. I hope you have fun exploring everything Maya has to offer, and I'll see you in my next video.